Here we're going to look at a problem from the 2006 International Math Olympiad. This is question 4, and the goal is to determine all integers x and y such that 1 plus 2 to the x plus 2 to the 2x plus 1 equals y squared. So before we get into the solution, let's look at some hints so that you can maybe try it on your own. The first hint is that if x comma y forms a solution, then x comma negative y also forms a solution. And that's because y only shows up in this equation as y squared. So really, we only need to look for non-negative values of y. And in fact, you can tell that y equals 0 is not a solution, so you really only need to look for positive values of y. Then the next hint is to reorganize and factor this equation. Play with some evenness and oddness of things in the new equation after that reorganization. And then finally, you'll build a quadratic inequality, which will finally allow you to solve this. Okay, so hopefully you can give this a really good go with the hints, and then we'll come back with the solution. Okay, so now we're ready to look for a solution. So I first want to show that no negative values of x will work, and then we'll find a solution for a 0 value for x, and then argue what we can get with all positive values of x. So let's first of all notice if x is less than 0, well, that really means that x is less than or equal to -1 because we're inside the integers here. But what that tells us is that 2 to the x is less than 1/2, and 2 to the 2x plus 1 is less than 1/4. Great. But now let's notice that that means that 1 plus 2 to the x plus 2 to the 2x plus 1 is less than 1 plus 1/2 plus 1/4, and that's most definitely less than 2. But this thing is also strictly bigger than 1. But now if this term right here, which is the left-hand side of the equation, was equal to y squared, then we would have 1 is strictly less than y squared, which is strictly less than 2. But there's no integer for which when you square it, you get a number between 1 and 2. So what that tells us is that there's no solution for x which are negative. In other words, x less than 0. So now let's look at the case when x equals 0. That's kind of a case on its own. So if we set x equal to 0, notice that we get 1 plus 2 to the x plus 2 to the 2x plus 1 is the same thing as 1 plus 2 to the 0 plus 2 to the 1. But that's 1 plus 1 plus 2, which is equal to 4. And now if that's equal to y squared, then we get y equals plus or minus 2. So that means we have two solutions, and those solutions are 0, positive 2, and 0, negative 2, where this is the x part and this is the y part. Now the next thing that I want to notice really quickly is that there's also no solutions for x equals 1 and x equals 2. So if we set x equal to 1, let's notice that we have 1 plus 2 to the 1 plus 2 cubed, because that's 2 to the 2 plus 1, 2 to the 3. So here we have 8 plus 2 is 10, so that's 11 equals y squared. And there's going to be no solution for that because obviously 11 is not a perfect square. And now let's do the same thing for x equals 2. And so in this case, we're going to get 1 plus 2 squared plus 2 to the 5th. So 2 to the 5th is 32 plus 2 squared is 36, and then equals 37. So here we have 37, but again, 37 is not a perfect square, so there's no solution there. So for all x less than or equal to 2, we only have these two solutions, 0, 2 and 0, -2. So I'll go ahead and bring that up as a summary, and we'll move on to finding the rest of the solutions. Up to this point, we have shown that the only solutions with x less than or equal to 2 were 0, plus or minus 2. In other words, x equals 0, and then y can be plus or minus 2. So that means all we need to look at now are the rest of the integer values of x. In other words, x is bigger than or equal to 3. So let's go ahead and suppose we have a solution x, y, again with x bigger than or equal to 3, and see what we can do from that. So that means this equation holds. In other words, we have 1 plus 2 to the x plus 2 to the 2x plus 1 equals y squared. Now, if we look at that, we've got a y squared by itself on the right-hand side, but we can move this 1 over to the right-hand side and then factor using a difference of squares because we will have y squared minus 1. And that might be extremely helpful. So let's go ahead and do that. That's going to allow us to write 2 to the x plus 2 to the 2x plus 1 equals y squared minus 1, but that's obviously equal to y plus 1, y minus 1. Okay, fantastic. And now I can go ahead and factor this left-hand side a bit too. So notice I can take a 2 to the x out of this left-hand side. That's going to leave me with 2 to the x times 1 plus 2 to the x plus 1 equals y plus 1 times y minus 1. Okay, great. Now the important thing to notice here is that y plus 1 and y minus 1 are both even. And that's because the left-hand side of this equation is even. But that implies that the right-hand side is also even. But we know that y plus 1 and y minus 1 have the same parity. If they were both odd, their product would also be odd. So that means they are both even. So let's write that. So y plus 1 and y minus 1 are even. So that's really important to notice because now we can take their difference. So also notice that y plus 1 minus y minus 1 equals 2. But any linear combination of two integers is a multiple of the greatest common divisor of those two integers. So in other words, 2 divides the GCD of these, y plus 1 and y minus 1. But given the fact that they're both even, 2 is actually equal to the GCD. So in other words, we have 2 equals the GCD of y plus 1 and y minus 1. But what that means is that one of those is divisible by 2, but no larger power of 2. So let's go ahead and write that down. So y plus 1 or y minus 1 is divisible by 2, but not a larger power of 2. So we might as well just say, but not 4. Okay, great. So now I'm going to maybe hold on to this factorization and that fact, and we'll start the new board with that. So we just got done rewriting this equation and factoring it in the following form. So we have y plus 1 times y minus 1 equals, we had 2 to the x, but I've rewritten that as 2 times 2 to the x minus 1, and then times 1 plus 2 to the x plus 1. And this is pretty obvious, but maybe it's important to notice that this thing is odd. So that means all of the evenness of the right-hand side is contained in this bit right here. And then another thing that we argued on the last board was that the GCD of these two numbers was equal to 2, which means one of them is divisible by 2, but not 4. They're both even. We argued that before. But one of them is only divisible by 2 as its largest power of 2 for a divisor. But if one of them is divisible by 2 and not 4, then that means the other one is divisible by 2 to the x minus 1. So let's go ahead and write that down. So y plus 1 or y minus 1 is a multiple of 2 to the x minus 1. And you might say, which one is the multiple of 2 to the x minus 1? Well, it's whichever one is not divisible by 4. Okay, great. So now we're going to break this into cases. So case number 1 will be y plus 1 is a multiple of 2 to the x minus 1. In other words, we can write y plus 1 as 2 to the x minus 1 times m. And then notice here, we can say that m is bigger than or equal to 1 and it's odd. So let's argue why we can say that. So we can say that it's odd because if m was even, then that would imply that y minus 1 was odd because y plus 1 would take up all of the evenness of this side of the equation. But we know that they're both even. And then why can we say that it's bigger than or equal to 1? Because we only need to look for positive solutions because all negative solutions come paired with positive solutions. So that's why we have those two conditions over there. Okay, good. So now we can take this and reinsert it into our equation over here, obviously after we solve for y. So notice that's going to tell us that y is equal to 2 to the x minus 1 times m minus 1. Now let's go ahead and put that into this equation. So we have 1 plus 2 to the x plus 2 to the 2x plus 1 equals the quantity 2 to the x minus 1 times m minus 1, and all of that is squared. Okay, great. So let's see. That's going to give us 2 to the 2x minus 2 times m squared, and then minus 2 to the x times m. So that's twice this term times that term, and then plus 1. Great. And now let's see how we can simplify this thing. So notice we can get rid of the 1 on each side of the equation. Good. So now let's also take this equation and divide the whole thing by 2 to the x. And notice here we've got the extreme left and right-hand side, and all the terms in the left and right-hand side are divisible by 2 to the x. So let's go ahead and do that. We'll divide the whole thing by 2 to the x. And so that's going to give us 1 plus 2 to the x plus 1, that's what we get for this term, equals 2 to the x minus 2, so that's what we get for that term, times m squared minus m. Okay, fantastic. So I'm going to rearrange this a little bit. I'll move this m over and then this 2 to the x plus 1 over. So that's going to give me m plus 1 equals 2 to the x minus 2 times m squared minus 2 to the x plus 1. Great. Now what I want to do is factor a 2 to the x minus 2 out of the right-hand side of this equation. So we have 2 to the x minus 2, and then we'll have m squared. And then what's left over after we factor a 2 to the x minus 2 out of that? Well, it would be 2 cubed or 8. So in other words, we have m squared minus 8. Okay, so now I want to look at the extreme left and right-hand side of this, and we'll move that up, and that's where we'll pick up the argument. So we're still working on case 1, so that's when y plus 1 is an odd multiple of 2 to the x minus 1, and we work that down to the following equation. So we have m plus 1 equals 2 to the x minus 2 times the quantity m squared minus 8. So recall that we're still working off the case when x is bigger than or equal to 3, which means x minus 2 is bigger than or equal to 1, which means this 2 to the x minus 2 is bigger than or equal to 2. So that means I can build this inequality. This is bigger than or equal to 2 times m squared minus 8. But now we can look at the extreme right and left-hand side of this inequality, and we've got something to work with. So now we can rewrite this inequality to get 0 on one side, and that'll give us 2m squared minus m. So that's what we get if we move this m to the other side. And then notice here we have minus 16 and then minus another 1, so it'll be minus 17 is less than or equal to 0. So notice the orange inequality, which I've underlined, is equivalent to this inequality just by rearranging. The next thing to notice is if we look at the graph of this, it's an upward-facing parabola that goes through the vertical axis at negative 17. So that means it has 2 real roots. And the general picture of this looks like the following. Great. And so we want all of the m values that put us below the horizontal axis, but are bigger than or equal to 1 and odd. So they'll be in this region right here. So we can find those by setting m bigger than or equal to 1 by that condition, but less than or equal to the largest root of this quadratic equation. So let's notice that that's the same thing as 1 is less than or equal to m, which is less than or equal to, let's use the quadratic formula for this. So we have negative b, so that's 1, plus the square root of b squared, so that's going to be 1, minus 4 times a times c. So that's 4 times 2 times negative 17. So that's going to be negative 136. So that's going to be plus 136. And then all of that is over 2a. So that's going to be all over 4. OK, good. Now you can quickly approximate this number right here and notice that it is less than 4. So what that means is the only possibilities for m are 1 and 3. So let's go ahead and write that down. M equals 1 or m equals 3. So if m equals 1, going back up to this equation, we have 2 on this side of the equation, but then we have a negative number on the right-hand side of the equation. So in other words, m equals 1 is not a possible solution. So now let's go on to m equals 3. And that's going to turn this equation into 3 plus 1, so that's equal to 4, equals 2 to the x minus 2. And then we have m squared minus 8, so that's going to be 3 squared minus 8, or 9 minus 8, which is just 1. So we have 2 to the x minus 2 equals 4. But what that tells us is that x minus 2 is equal to 2. But that's the same thing as saying that x is equal to 4. So now we'll put x equals 4 into our original equation to find y. So that gives us 1 plus 2 to the 4 plus 2 to the 9, because that's 2 times 4 plus 1 equals y squared. So this is just an arithmetic calculation, so I won't do the details. But what you'll end up with is y equals plus or minus 23. OK, good. So we have a new solution. X equals 4, y equals 23, and x equals 4, y equals negative 23. And that all comes from this first case where we have y plus 1 can be factored this way. So now let's do the second case where y minus 1 can be factored this way. So we just worked through this first case, which was when y plus 1 was a multiple of 2 to the x minus 1, but not a multiple of 2 to the x. And so now we're going to work through this second case where we have y minus 1 is 2 to the x minus 1 times m, where m is odd. OK, so now what we want to do is write this as y equals 2 to the x minus 1 times m plus 1. And now we'll roll this back into the original equation. So that's going to give us 1 plus 2 to the x plus 2 to the 2x plus 1 equals 2 to the x minus 1 times m plus 1 quantity squared. So now if we multiply out that right-hand side, we'll get 2 to the 2x minus 2 times m squared plus 2 to the x times m plus 1. And now we can cancel out the 1 on both sides of the equation, and then also divide both sides of the equation by 2 to the x, just like we did before. And so that's going to leave us with 1 plus 2 to the x plus 1. That's what we get when we divide that by 2 to the x, equals 2 to the x minus 2 times m squared plus m. So now we'll play a similar game that we did before. Let's rearrange this a little bit. I'll move the m over in this direction and the 2 to the x plus 1 over in the other direction. That'll leave us 1 minus m equals 2 to the x minus 2 times m squared minus 2 to the x plus 1. I can go ahead and factor a 2 to the x minus 2 out of the right-hand side. That's going to leave us with 2 to the x minus 2. And then we have m squared minus 8. OK, good. So let's notice since m is bigger than or equal to 1, we have 1 minus m is less than or equal to 0. So in other words, the left-hand side of this equation is less than or equal to 0. That means the right-hand side of this equation is less than or equal to 0. Notice 2 to the x minus 2 is always positive. So what that tells us is that m squared minus 8 is the thing that has to be less than or equal to 0. But what that tells us is that m squared is less than or equal to 8. In other words, m equals 1 or 3. And that's because m is bigger than or equal to 1 and odd. And those are the only odd numbers that are bigger than or equal to 1 that satisfy m squared is less than or equal to 8. But if you notice, m equals 1 does not work in this equation, and m equals 3 does not work in this equation. So none of these lead us towards an additional solution to our problem. OK, so now we found all the solutions. I'll clean up the board and we'll have a summary. So let's look at a quick summary of this problem. So we first showed that there was no solution when x was negative, when it was 1, or when it was 2. We showed that if x was equal to 0, then y equals plus or minus 2 was a solution. And then finally, we showed that the only solutions when x were bigger than or equal to 3 were x equals 4, and then y could be equal to plus or minus 23. Okay, so now we finished this problem, and that's a good place to stop.